All right, in this video, now that you've had a chance to play with the simulation a little bit, I want you to just very roughly sketch a ray diagram here in your notes. So you can see this example. And what I want you to do is just follow along with this, and we'll draw each one of these lines independently. And we're going to start this with an object, and I'm going to use an arrow. We're going to use an object that's between the center of curvature F, or C, and the focal point F. And we're going to draw the three rays. And don't worry if this is not perfect. Just sketch it and try to do it the best you can. We're going to draw the first ray is going to come in parallel. And when it strikes the mirror, it's going to reflect through the focal point. So that'll be our first ray. Our ray number 2 is going to start at the same point. It's going to go to the principal axis. Bear with me 1 second. It's going to go to the principal axis. And then from the principal axis, it's going to reflect off into the distance. The last one is going to start here and come through the focal point, and then it's going to reflect off parallel. So even though I was drawing this on a computer screen, it's a little bit sloppy. You can see that the three rays drawn 1, 2, and 3 all eventually converge. This is where they converge here. It's the point on the image that's on the point that we drew the start at the image from. So we started the image at the top of the arrow, or at the top of the object. So then it converges on the top of the image. So we can draw in our image here, and it's an arrow. Moving on to some of the mathematics about this. Up to this point, we've been just looking at diagrams. There's another methodology for looking at images, and this is primarily what you're going to be doing on your assignments and on your quizzes. It's going to be asking you about the image location. So you're going to be looking at statistics about it. In order to do that, you got to first get a handle on some of the notation. The D subscript O is what we use for the object, and the D subscript I is what we use for the image. Those are both distances from the mirror to the image and from the mirror to the object. In fact, all subscripts O and I will be used consistently, and the O's will be the object and the I is the image. So the light stems from the object, bounces off the mirror, forms again at the image. When we talk about the image height and the object height, we can give these both by H with the subscript O for the object and the subscript I for the image. And if your image is real, meaning that if you can have it be projected onto a screen, for all mirrors, what's going to happen is the image is going to be on the same side as the mirror as the object. Because if the image is forming on the silvered side, which is the side that it would start with, that means that the light must actually pass through that point. So that is another way, if you're looking at a diagram, to sort of identify if it's real or virtual. I'm looking at a couple of equations, and you're going to use these equations in some practice at the end of this. We have an image location equation, and basically it compares the distance of the object, the distance of the image, and the focal length. So if you add this up, 1 over dO plus 1 over di equals 1 to f, you can figure out from two of these three variables, dO, di, or f, the location. And generally what you start with is an object and a focal length, and you'll, in general, most likely be asked for the image distance. If we want to understand the magnification, because we do have notation for the heights, we can say that the magnification is equal to the initial height, or the height of the image, divided by the height of the object, or the distance away from the sphere the object is compared to the distance away from the sphere the image is. So if you look at each one of these ratios, both of them will give you the magnification that you would see in the image. Depending on how far away your object is from your image, the size, or how far your object is from the mirror, the size of that image is going to change as you vary that distance. So go ahead, on your next slide, there's an example, or there's a link to CAS Learning. Go ahead and try that, and then complete the form in our assignment, and we're all set.